I'll start from the first. Okay. We had a technical issue, so I'm going to start the class all over again. We didn't connect audio. So in the previous session, we were talking about resistors, variable resistors, and all that. In today's session, we are going to talk about acids and bases. With that said, let me put on the presentation. We are going to talk about acids and bases. We are not going to dive deep into the chemistry of acid and bases. We are just going to see a few examples of acid and bases in everyday life, and we are going to talk about indicators. So let's start the presentation. We are going to first look at common examples of acids and bases. Lemon juice, tomato juice, vinegar, and curd are few examples of acids that we use in everyday life. And other examples of bases are toothpaste, baking soda, soap, and stomach tablets or antacid tablets. So acids and bases are classified based on a pH scale. So pH scale starts from 0 to 14. From pH 0 to pH 6 is acid, and pH 7 is neutral, and pH 8 to pH 14 are classified as bases. So we will understand more about this when we talk about pH paper. So we are going to start with indicators. An indicator is a substance that is used to check whether a solution is an acid or a base. So indicators react with acids and base and give out different output, and depending on what output they give, we can classify that particular solution as an acid or base. Today's session will be focused mainly on indicators. We have different types of indicators. We have natural indicators, olfactory indicators, synthetic indicators, and we will start with natural indicators. These are indicators obtained from substances available in nature. A few examples are turmeric, China rose, and litmus paper. Turmeric, it is a turmeric that we have at home. Then we have China rose, which is a type of hibiscus. Then we have litmus paper. So you might be a bit surprised to find litmus paper here. Let me explain where we get litmus paper from. You might have heard of lichens. So lichens is an organism that is a combination of fungi and algae. So lichens is basically a symbiotic relationship between a fungi and algae. A symbiotic relationship is when two organisms live together and both of the organisms have a win-win situation. In case of a lichen, the fungi gives protection and helps the algae adapt to the situation, whereas the algae produces food. So basically, litmus paper is obtained from lichens, and since lichens is present in nature, litmus paper is also a natural indicator. So we are going to talk and experiment with turmeric as an indicator. Yes, you can use the turmeric at home. This demonstration that I'm going to show you, you can try it at home as well. It is very easy. All you need is some turmeric powder and a soap. So turmeric powder, when it reacts with acid, does not change color. It remains yellow itself. But on the other hand, when turmeric reacts with base, it gives a red color. So this is how we can use turmeric to identify whether that particular solution is an acid or a base. So I'm going to pause the presentation for now, and we are going to see the demo, and we are going to use the turmeric as an indicator. Let me show you a different camera angle. So I have turmeric water here. Basically, it is simply turmeric mixed with water. You can prepare it very easily at home. You can see that it is yellow in color. Then I have soap solution. Basically soap and water. You can just wash your hands with the soap and pour the water into a bowl, and that will be soap solution. Let's mix it. So turmeric is yellow in color, soap solution is white in color. Soap solution is a base. Let's verify that using the turmeric water. I'm going to take some turmeric water and pour it into the soap solution. And I'm going to mix it. Let's add more and mix it properly. Now you can clearly see the difference. Turmeric is yellow in color, and our turmeric has reacted with the base and changed into a reddish orange color. So now we can conclude that turmeric combines with base to give a different color, reddish brown color. So that means turmeric is able to identify a base. So let's try turmeric with an acid and check if there is any color change. For acid, I have a lemon, which is citric acid. I'm going to squeeze it into the cup. So we have lemon juice here, which is citric acid. I'm going to pour some turmeric into this lemon juice and check if there is any color change. Now we can see that it is yellow in color. Let me transfer this to a white cup so that you can see the difference in color. So here we have turmeric with an acid and turmeric with a base. We can see that turmeric with acid has retained its color yellow, but turmeric with base has changed its color to red. So you can try this activity at home. It is very easy. All you need is some turmeric powder and some soap water and lemon juice. We are going to keep this aside for another experiment that we are going to see at the end of this session. We'll keep it as it is. So going back to the presentation. So we just saw how turmeric can be used as an indicator of an acid or a base. Now we are going to see the second example, which is litmus. So litmus, we obtain it as blue litmus paper and red litmus paper. You might have used it in your labs. So acid plus blue litmus paper reacts to give red color, whereas base plus blue litmus paper does not produce any color change. And we have another type of litmus paper, which is red litmus paper. Again, acid plus red litmus paper does not give any color change, whereas base plus red litmus paper changes to blue color. So let's do that experiment right now. I'm going to pause the presentation. I'm going to change the camera view. So here I have blue litmus paper and red litmus paper. Let me take a strip of red litmus paper and a strip of blue litmus paper. Let me take some again acid, citric acid from lemon. So I have some lemon juice in this. Okay. Now if you remember, the blue litmus paper must change to red when it is reacting with acid. I have just dipped red litmus paper into the acid. There is no color change. Let me keep it here. So now red litmus paper with acid, no color change. Blue litmus paper with acid. So this is red litmus paper plus acid. There is no color change, but blue litmus paper has changed to red. Let me show you an intact blue litmus paper. This was the blue litmus paper, but after dipping in lemon, it has changed to red color. Now let's take a base and check red litmus paper. So I have some cleaning liquid. This is a base. Let me pour some into the cup. This is a base. Now let's dip a red litmus paper into this. A red litmus paper will react with base and become blue. Let's check with the blue litmus paper. Blue litmus paper is not supposed to react with the base, so there won't be any color change. So here we go. Red litmus paper plus base has changed to blue color, whereas blue litmus paper, there is no color change. Red litmus paper and blue litmus paper are easily available in laboratory stores. You can get them. It is very cheap and you can experiment this at home as well. So coming back to the presentation. So we saw about turmeric and we just experimented with the litmus paper as well. Now we are going to talk about olfactory indicators. These are an interesting category of indicators. These indicators, their smell changes depending on whether they are exposed to an acid or a base. So three common examples of olfactory indicators are onion, clove, and vanilla. Onion and clove, you can find it in your kitchen. Let me tell you how to do that. This will be a homework for you today. Take onion and mix it in a blender or a mixie, and using a strainer, take the onion juice out of the pulp and keep it separately. This onion juice, when it mixes with acid, retains its smell, that pungent smell, but once it mixes with base, it will lose its smell. So this is how onion juice can be used to classify an acid or identify an acid or a base. Onion juice plus acid, no smell lost. Onion juice plus base will lose its smell. You can try the same with clove. Next time you make biryani, steal some cloves and repeat the same experiment. Clove plus acid will retain its smell. Clove plus base will lose its smell. So this will be activity for you today to try at home. Another category of indicators are synthetic indicators, phenolphthalein and methyl orange. These are indicators that are synthesized at laboratories. So we don't have it right now. We are more interested in the next category of indicators, which is universal indicators. So universal indicators are a collective mixture of different indicators. So they show a wide range of colors. You remember we talked about this pH scale. So this pH scale is given by an universal indicator. You can use an universal indicator to get these different shades of color to identify whether it is an acid or base. So now you might be wondering, what is the difference between an universal indicator and a litmus paper or turmeric? Let me give you the answer. Using turmeric and litmus paper, we were only able to find out whether that particular solution is an acid or a base. But using a universal indicator, we can find out how acidic that particular solution is or how basic that particular solution is. Basically, universal indicators will give us an extra information about how strong or weak the acid or base is. Okay, so that is when we have a pH paper. So acids and bases react with pH paper to give different shades of colors. Depending on what color they give, we can classify them as acid or base. From 0 to 6. So these numbers represent the pH of the solution. From 0 to 6 pH, we classify those liquids as acids, and 8 to 14, they are classified as bases. In the middle, we have neutral, which has a pH of 7. So before we go into neutralization reaction, let's have a look at few examples and understand their pH using the pH paper. So this is the pH paper, orange in color. Let me show you a different camera angle. So this is the pH paper and this is the pH scale. So I have taken the pH scale in a separate chart like this. pH 1 all the way to pH 14. pH 1 is as acid and 7 is neutral and 14 is basic. So this is the pH paper, orange in color. Okay. So here we have a few examples. Let's start with lime juice. Lime juice is citric acid. So it must have a pH of around 1 or 2. Let's check it out. So right now the color is orange. I'm going to dab a few drops of lemon juice onto the pH paper. And now the color has changed to maroon or red. Let's match it with the pH scale we have. So this is pH 1, pH 2, pH 3, all the way to pH 14. So the pH of lemon juice is around 1. It's between 1 and 2. So that means it is a strong acid. So acid is there. Let's try with a different solution. Let's take a cleaner. If you remember from the previous demonstration, a cleaning liquid is a base. So looking at the pH scale we have right now, beyond 7 it is base. So the color that the pH scale must give with the cleaning liquid should be somewhere between, should be grade of 8 to 14. It must be green. Let's check that out. Here we go. We got green. So this proves that our cleaning liquid is a basic solution. So that is cleaning liquid. I hope you know curd is made up of lactic acid. So that is an acid. So what do you think will happen if we dip pH paper into lactic acid? It must have a pH below 7. So it must be a shade of red or yellow. So let's check that out. So here we go. pH paper plus lactic acid or curd is having a pH of about 5 or 6. Okay, 5 or 6. So that means it is acidic in nature. So that is curd. Let's try with vinegar. Vinegar is acetic acid. So let's try with vinegar. So pH paper here, orange color with vinegar. Oops. Yeah. So here we go. We got pH of 1 or 3. So let me keep this aside for a while and get some fresh tissues. Okay. So let's use the litmus paper again and try to find out what advantage we have from the pH paper over litmus paper. So here is the blue litmus paper. Blue litmus paper reacts with acid to give red. So it is blue has turned to red. So here is blue litmus paper reacting with an acid to give red color. Let's take another strip of blue litmus paper and lemon juice. Again, blue litmus paper has changed to red. But right now what we don't get to know is whether this acid is strong or this acid is strong. To know the strength of an acid or a base, we will have to use a pH paper over litmus paper or turmeric. That is why it is called an universal indicator. So let's try a few more examples. I have a carbonated drink. Pepsi, Coca-Cola, Sprite are all examples of carbonated drink. So these drinks are basically acidic because they contain an acid called carbonic acid. So let's check the acidity of this carbonated drink. For that, let me grab a pH paper. And pour it into this cup. That proves that it is carbonated. So pH paper plus acid. So here we go. It is mildly acidic, somewhere near 3 and 4. So here we have an acidic solution. Let me try that with once again with lemon and show you the difference. So here is a difference in color. This one is carbonic acid and this one is citric acid from lemon. So now we can see the different shades in color, meaning that this is stronger. pH 0 is strong, and as we move down the scale, it becomes weaker. Similarly, pH 8 is weak base and pH 14 is strong base. So now we can see that lemon juice has a pH of about 1, whereas carbonic acid has a pH of about 3 or 4. So that means lemon or citric acid is stronger than carbonic acid. So this is the advantage of litmus paper. We can find out the strength of an acid or a base using the pH paper. So let's go to the presentation. We have neutralization reaction. So what happens when, just a second, what happens when acid and bases react, right? They don't dramatically produce a smoke or something like that. They form an salt and water. So this is called neutralization reaction. It is called neutralization reaction because it neutralizes the pH. So let's understand neutralization reaction with an example. Okay. If you remember, this is the mixture of turmeric with soap water. It has turned red. This is the turmeric. So this is the turmeric, yellow in color, with soap water, red in color. So right now, this is basic solution because turmeric is neutral, but we have a base mixed with turmeric. So this right now is a basic solution. So now what will happen if we add acid to this? Let's see if there is any change in the color. Before that, let's take 2 different cups. Let's pour a little bit into this. Okay. Now we have a red solution, which is basic in nature. Let's add an acid to check if this base is getting neutralized. Observe the color change. Let's stir it. So it has turned to yellow. That means the basic nature of the solution has been neutralized. So right now we just witnessed a neutralization reaction. So apart from this, neutralization reaction has got very important applications in our day-to-day lives. Let's explain that. Let me go to the presentation for that. Escape. Let me share the screen. So the first example is about acidity in stomach. Let's understand the scenario. When our stomach, usually our food is digested by a strong acid called HCl. Usually it is secreted in required amounts, but sometimes what happens is this HCl is secreted more, and this can cause acid reflux or burning sensation. So this is called acidity. When we have acidity, we treat it by eating antacids. So antacids are bases. So the acid in the stomach, when it gets more acidic than what is meant to be, we eat antacids, which are bases. This base and this acid react and neutralize to reduce the burning sensation. Duplicate. So antacids contain magnesium hydroxide and other bases. Let's see that reaction right now. I have some Gelusil. So Gelusil and Digene are common examples of antacids in medical shops. You can get it in medical shop. You can try this activity at home as well. All you have to do is either get the syrup version of Gelusil or Digene, or you can get tablets and grind it into a powder like this. I'm going to mix some water into this. So if you remember, this is a base, and we are going to get a basic solution right now. Let's stir it. It is not consistent, but still we've got a basic solution with us. Let's check the pH using the pH paper. Okay, pH paper I have with me. It has turned to green. Let's take the pH scale. So it is somewhere between 8 or 9. That means it's a weak base. So right now the pH of this particular solution is basic. So let's keep that aside. Let's use citric acid again. And check the pH. So what we're trying to do is we are going to mix an acid and a base to check if the pH is getting neutralized. Let me get a fresh lemon. Here is some lemon. Let's squeeze it. So here I have lemon juice, acidic in nature. Let's check the pH. Here we go. So this is antacid, basic. This is lime juice, acidic. I'm going to mix this antacid and citric acid and check if this pH is getting reduced or increased towards the basic side. Let's add this antacid. This is just a demonstration. Please do not consume Gelusil without any doctor's prescription. And doesn't mean that if you eat lime, you will have acidity. Does not mean that. This is just a demonstration. Let's add more antacid and check if we are able to neutralize the solution. Let's check the pH again. So here we have it. Let's remove this. So this is antacid. This was our citric acid, and we have reduced the pH. It is still not neutralized, but we were able to reduce the pH. This is towards 1, but this is reduced to about 3 or 4. This once it was a strong acid, but we used a base to neutralize this acid to some extent and make it slightly less acidic. So this is a good example of neutralization reaction. In our stomach, as we consume an antacid, they are able to neutralize the excess acidity in the stomach, and there also a neutralization reaction takes place. Escape. So next example we are going to see is a very important one, a very important habit that we all must follow. I'm hoping that everybody is already following this, that is brushing our teeth. Brushing our teeth. So let me explain the scenario here. Our mouth has microbes living in it. So our teeth is covered by a protective layer called I'm not deep. No, it's okay. Okay. Our teeth is covered by a protective layer called enamel. So enamel protects our teeth. Enamel is strong, but the only weak point of enamel is chronic exposure to acidic nature will slowly degrade it. Meaning if the environment in which the enamel is acidic, it will slowly get degraded. That is why we always, doctors recommend us to brush our teeth. So the microbes living in our mouth, they consume the food that we eat. If we don't brush properly, the food particles get stuck between our teeth, and they consume this food particles and secrete acid. So this acid slowly degrades the enamel. So that is why we have a natural protecting system, which is the saliva that we have. Our saliva is basic. I don't want to show it here because it will look gross. But when we dip litmus paper, pH paper in saliva, we will get a green shade, which means that our saliva is basic. So this basic nature of the saliva naturally helps protect the enamel. But since we eat food and this food can get stuck between our teeth, this bacterial secretion turn the teeth mouth environment into an acidic nature. So this acidic nature is not good for our teeth. That is why we must brush our teeth. Why should we use a toothpaste? That's because toothpaste is basic in nature. You don't have to trust me. Let's see that in action. I have some toothpaste with me. Let me switch the camera angle. I have some toothpaste with me. You can try different paste. I am using this one. Let me get a cup. So here I have some toothpaste. You can try this at home. It is very easy. All you have to do is squeeze some toothpaste into a bowl. And we are going to mix some water. And let's stir it to get a consistent solution. So as we eat food, these microbes secrete acids that make our mouth acidic in nature. So when we brush with a proper paste, the basic nature of the paste neutralizes the acids and protects our enamel. So here we have a solution of paste. It's white in color. We are going to use the pH paper to check the nature of this paste. Let's dip it. Wow. Here you go, green color. Bringing the pH paper alongside, green and green. So this means our paste is slightly basic in nature. So this is why toothpastes are basic. They help prevent or neutralize the acidic nature of our mouth and help protect our enamel. So these are very two common examples of neutralization reaction in our everyday life. One is antacids, the tablets that we use to reduce acidity in our stomach. They also perform neutralization reaction to reduce the pH of the acid and neutralize it. That is one example of neutralization reaction. And another example of neutralization reaction is toothpaste. Toothpaste help neutralize the acid in our acidic nature of our mouth and help protect our enamel. So these two are common examples of neutralization reaction. Even some of other examples of neutralization reactions are production of NaCl. That is another example of neutralization reaction. But these two are very common examples that we can see in our everyday life. So this is all for today's class. We are going to have a recap right now. We started by talking about acids and bases. A few common examples were lemon, tomato, and all that. You can try the experiments that we tried today in this session at home using turmeric or water, or even if you can buy some litmus paper, you can try those activities. So we talked about natural indicators. Then we talked about turmeric. We talked about blue litmus paper and red litmus paper. Then we talked about olfactory indicators. These indicators change their smell depending on whether it is an acid or base. I highly recommend you to try this at home. It is really interesting. I have tried it out. The most easiest thing is using a onion. You can use onion, take the juice and try it out. And then we talked about synthetic indicators, phenolphthalein, methyl orange. And then we have the hero, which is the universal indicators, which not only tell us whether a solution is acid or base, but also give us one extra information as to how acidic or how basic that particular solution is. So that is universal indicators. We use pH paper. So when we talk about pH paper, we have the pH scale all the way from 0 to 14, 0 to 6 being acidic, where 0 is most acidic, strongest acid. As we move towards 6, the strength of the acid reduces. A few examples of strong acids that we saw in the session were citric acid, and then we used acetic acid. They were all strong acid. Acetic acid is nothing but vinegar. You can get vinegar and citric lemon juice very easily. You can try with tomato also. It is also an acidic fruit. You can check the pH of these fruits, and then from acid to neutral we have 7, where neutral means water is neutral. You can check the pH of water, it will be green. It won't it is neither acid nor base, it is neutral. Then we have bases which have the pH of about 8 to 14, 8 being the weakest base, and as we move along till 14, 14 being the strongest base. So a pH scale will help us understand whether a solution is acid or base, and also give us the information about how acidic or how basic that particular solution is. That is the importance of pH paper. And then we talked about neutralization reaction, where acid and base combine to give salt and water. Without seeing any chemical reactions, we just pointed out two very important, very common examples of neutralization reaction, which is acidity in stomach and toothpaste. So this is all for today's session. I hope you enjoyed. Please try the activities at home. See you next time. Thank you.